So we're going to continue our coverage of reactive programming, focusing now on the key classes in the RxJava API. And you should now have your programming assignment out and ready to go, so you can start taking a look at that. What we're going to cover over the next couple weeks are the topics related to that assignment. So let's talk about some of the key classes in RxJava. And you'll see that they're called single, flowable, and observable. So the three key classes in the RxJava API, and then two other ones that are kind of variants of one of the classes we'll talk about. The first one is called single. And a single will complete successfully or not, and it may or may not emit a single value, which is why it's called single. It's somewhat similar to a Java completable future, or another way to think about it is like an optional that's async, if you're familiar with the optional class. And you should be familiar a little bit with that because we've talked about it a couple times. You can document and understand the behavior of operators in the single class using something called a marble diagram. And you can read more about marble diagrams at this link. This is how the reactive programming APIs are documented. So the way you read this is there's a timeline from left to right. And this is the item that's emitted by the single. And this indicates that a transformation will be applied to that item. So that's the little box here. And the text inside the box indicates the type of the transformation, and that's usually a method, like map or flat map or do on success or whatever. Then there's a result of the transformation. So it'll give a result as a result of applying the operator on the input. And if things go well, there's a vertical line that says we're done and everything's succeeded. If there's a failure, then there's a line that indicates that something's gone wrong. So those are basically kind of how you read the marble diagrams. There are a lot of operators in single. You will find this with all the classes in reactive programming. There's typically dozens, if not hundreds of operators there, many of which are overloaded. But they typically fall into certain categories. They're factory method operators, they're transforming operators, they're action operators, there's operators for concurrency and scheduling, there's operators for combining stuff, there's operators for suppressing and blocking, and so on and so forth. And you'll see that there's similar styles of operators for flowables and observables as well. There's a variant of a single called a maybe, and a maybe may emit a single value, no value at all, or an exception. And here's an example of a maybe. This particular code is going to generate a stream of values from 1 to n. It'll map those into big integers, and then it will reduce them by multiplying the big integers together to give a single reduced result. If n is 0, there will be no output at all. So that's why reduce returns a maybe, which may not have an output. So it may succeed, but it may not have an output. Whereas a single will either succeed or fail, but it'll always have an output if it succeeds. A maybe may not have an output, even if it succeeds, because it may have had no input. The next class we're going to talk about is called the observable. It emits an indefinite number of events, namely 0 to infinity, which may or may not succeed. So you may or may not get success, and we'll talk about what happens when things fail later. You can think of observable as something akin to an asynchronous Java stream. For example, we talked about before, and you've got a chance to play around with Java streams where we had completable futures in a stream. So you'd have a stream of completable futures, and the operations would run asynchronously, but we would stream them together using the stream syntax and semantics. And basically, the same kind of idea comes with observables. So, for example, here we might create we might have a big fraction that we're going to reduce on some scheduler, and we're going to go ahead and multiply that together with some other value and do it concurrently. And all those things will take place asynchronously. They'll run in the background. Observables are also documented by marble diagrams. The main difference is there can be more than one thing emitted from an observable, whereas with a single, you can only emit one thing. As before, there's a flow of data from left to right. There are items that are emitted by the observer. This box indicates the transformation that'll be applied by the observer using typically some operator like flat map or reduce or whatnot. And then you get results that come out. If everything goes well, we've finished successfully. If something goes wrong, we have a little X that indicates things failed. Once again, there's a boatload of operators for observables, just like there are for singles. The main difference usually being that they work on a stream of things, whereas a single only works on one thing or only emits one thing, typically. And then the third kind of class that's important is called a flowable. And this is a generalization of observable that supports so-called back pressure. If you recall from our earlier discussions about this, the idea behind back pressure is to prevent the situation where a fast-running publisher generates data more quickly than a slower-running subscriber can handle. And so by using back pressure, you can have the subscriber say, hey, only send me a certain number of items, only send me 3 events, and then I'll process them, and I'll let you know when I can get the next chunk of stuff. So it's a way of trying to institute what's called flow control or back pressure. There's another key thing that Flowable supports, which we will hopefully get a chance to play around with in the final programming assignment in this class, which is the ability to have parallel flowables. And so it's a nice way to kind of build in or bake into the programming API the concept of handling or processing streams of data asynchronously in parallel. And so parallel flowables will be important, and you'll get a chance, hopefully, to play around with that for the assignment number 4B. So that's the end of the overview of key classes in the RxJava API.